evaluate this line integral where c consists of the arc of the circle x square plus y square equals 4 from 2 0 to 0 2, followed by the line segment 0 2 to 4 4. Okay, so this is the equation of unit circle, not unit circle, standard circle with radius 2. So we have this portion of the circle. This is 2 0. Okay, here 2 0 and here 0 2. And let's say this portion of the circle be C1, just this part, and we have a line segment from 0 to here to 4 4. Let's say that's C2, and the given curve C, that is C1 plus C2. Okay, just C is C1 C2, C1 union C2. Let's parameterize this C1 curve. Since we have a circle, it's pretty much quarter circle, so with radius 2, cosine sine for unit circle, since we have radius 2, we multiply by 2, so x equals r cosine t, that means 2 cosine t, y is 2 sine t, and look at the angle here, just 0 through pi over 2. That's for C1. Now for C2, which is a line segment from 0 2 to 4 4, so xy will be always first point times 1 minus t plus second point times t, where t runs from 0 to 1. So 0 to first point times 1 minus t plus second point times t, that's xy. And just to find x, we multiply 0 times 1 minus t, which is 0, plus 4 times t, 4t. So x equals 4t. Once we have x, now we go for y, and y is just second component, so 2 times quantity 1 minus t plus 4 times t, so 2 minus 2t plus 4t, 2 plus 2t, and t runs from 0 to 1. Okay, so let's evaluate this integral on C1 first. Next we need to find, we have dx. Look at the question here, we have dx, and we need to convert this in terms of dt, and we know that x is 2 cosine t, so dx over dt, derivative of this with respect to t is derivative of x is 2 times negative sine t, so negative 2 sine t dt. We need this. Okay, and we also need dy, so let's find dy as well here, dy over dt, but I want to write in differential form, 2 cosine t. Then on C1 curve we have the bounds for t 0 to pi over 2. The integrand is x squared dx plus y squared dy. So x squared means 2 cosine t squared, 4 cosine squared t, times dx is negative 2 sine t dt plus y squared, that's 2 sine t squared, 4 sine squared t times dy 2 cosine t dt. Okay, we can factor something out, but that does not help, so let me split this into two integrals. In the first 4 times negative 2 negative 8, we can pull outside, 0 to pi over 2, that leaves cosine squared t times sine t dt, plus second part is 0 to pi over 2, 4 times 2 8, we can pull outside, 8 outside, and we have sine squared t cosine t dt. Okay, so we got a product, and we know derivative of cosine is negative sign, so we can use u sub, and same thing here. So if we take u be cosine, then this is u squared, and derivative of cosine is negative sign. We don't have negative, but we can always multiply by -1, or this negative we could have left inside here, this negative just here. Then this is u is cosine, derivative of cosine is negative sine t dt, that's du part. Similarly here, sine t is u, so this becomes u squared, and derivative of sine is just cosine. We don't need negative here, this is du. So this is same as 8 outside u squared du, so u3/3, that means cosine cube over 3, and we evaluate from 0 to pi/2 plus 8. Same thing here, u3/3 sine cube t over 3, go from 0 to pi/2. Now 8 upper limit, this 3 can be pulled outside. In fact, 8/3 cosine pi/2 cube, cosine pi/2 is 0, cube is just 0, upper limit part, minus, plug in 0, cosine 0 is 1, 1 cube is 1, plus 8, 3 can be pulled outside, sine pi/2 cube, sine pi/2 is 1 cube 1, minus sine 0 is 0. So this is negative 8/3 plus this is positive 8/3. So the resultant is 0. Okay. So on C1 the integral is 0. Now we need to do on C2, which is a line segment here. Okay. From here to here we have this parameterization. X is 4t, y is 2 plus 2t, where t runs from 0 to 1, and then the integral here is t 0 to 1. Okay, if we look at the question, we have x squared dx plus y squared dy. Oh, so we need dx and dy, so let me find that first before I write this. So x is 4t, so dx over dt is 4, derivative of x with respect to t, so we write t here, and dy over dt is derivative of 2 plus 2t is just 2 dt. Then on C2 0 to 1, and the question is x squared dx plus y squared dy. Okay, so x squared means 4t squared, 16t squared dx, which is 4 dt, plus y squared 2 plus 2t quantity squared times dy, which is 2 dt. So it's pretty much calculus 1 now. Let me separate into 2 due to this plus. In the first term, 16 times 4, 64, 0 to 1, t squared dt, plus integral, here we can pull 2 outside, and this is 2 plus 2t squared. We can factor 2 out from these two terms, by the way. That's 2 squared, 4 outside. So we have 2 squared 4 outside, 4 times 2, 8, and that leaves 1 plus t quantity square dt, and 0 to 1. So let's integrate these. T squared t 3 over 3, we can put 3 here, by the way, 0 to 1, plus 8. Derivative of 1 plus t is just 1, so we can use the simple power rule here. 1 plus t 3 over 3, 3 can be pulled outside, 1 plus t 3, and divided by the coefficient of t, which is 1, so we don't have to worry. Divided by 3 is here, 0 to 1. This is 64 thirds, upper limit 1 minus 0, just 1, plus 8 thirds, upper limit 1, 1 plus 1, 2, 2 cube is 8, minus 1 plus 0, 1 cube is 1. So this is 64 thirds plus 8 minus 1, 7. 8 times 7, 56 thirds. 10, 12, 120 thirds, which is 40. So thus the final answer for our curve C, x squared dx plus y squared dy is first curve 0 plus 40, so 40. Okay, so final